Good morning, viewers. Welcome to MouShauk. We'll start with today with atmospheric pressure. This is according to class 9 syllabus, ICSE, and I was discussing about pressure in fluids and atmospheric pressure. So we'll start with atmospheric pressure today. So before I start, I will request you to please to subscribe my channel if you have not subscribed yet, and if you are a new viewer to my channel. And if you are liking the videos, press the like button, share with your friends so that they can be uh, also be benefited from these videos. And if you have any doubt regarding this chapter or any other chapter which I am discussing so far, please do write in the comment box, or you can also write in my email ID, that is Kasturi, Kasturi 74 @gmail.com. Okay. And one more thing, you will find the links of the above other videos of this chapter, as well as the playlist of the physics, the biology and chemistry and the other physics chapters. Links are also provided in the description box. Please have a look there. And also there's a link to my new channel. It's a Bengali channel, which I have started. It's a spiritual Bengali channel. If you are interested in that, you can also refer to that link also. Okay. So before I start, I will start with a short meditation. Okay. And then we'll start with the discussion. So for meditation, just just concentrate on a point of light. Think that light is falling on you, and your whole body is enlightened. You are feeling energetic, feeling happy, and getting interest in whatever you are doing. You're feeling that you are blessed. You have become powerful. You are the loveliest son of God, and you are being helped by Him at every step of your life. And at the end of the day, you are becoming successful. And so you are thanking God for being with you at every step. Okay. So let us end here by thanking Him. Okay. So let us start with atmospheric pressure. So what is atmosphere? Atmosphere is an envelope of air which is surrounding you or surrounding the earth. Okay, that is known as atmosphere. So you are present on the earth. So surrounding you, there's an envelope of air which is known as atmosphere. This atmosphere, which extends up to 300 kilometers above the Earth's surface, and it clings to the Earth due to its gravity. Due to the gravitational force of the Earth, the air is hanging, or it's very close to the Earth. It's just above the Earth. Okay, if there had been no gravitational force, the air would have not been present there. Okay, the atmospheric air exerts a force on all the objects in the atmosphere and also on the earth. So the force or the thrust that is exerted by the atmospheric air on an unit area is known as atmospheric pressure. Okay, so what is atmospheric pressure? It is the force or thrust by the atmospheric air on a unit area, that is known as the atmospheric pressure. The approximate value of this atmospheric pressure on the Earth's surface is 1.013 into 10 to the power 5 pascals. 10 to the power 5, not 105, but it's 10 to the power 5 pascals. Okay. The atmospheric pressure at a point is the same in all directions. if the area of air column on the Earth's surface is say 1 centimeter square and weight of the air column is 1 kilogram force, then the atmospheric pressure will be weight by the area, that is force by area. So 1 kgf by 1 centimeter square, that will be equal to 1 kgf is equal to 10 Newton. So 10 Newton by 1 centimeter square, that is 10 to the power minus 4 meter square, that is equal to 10 to the power 5 Newton per meter square. Okay, that is the thrust of about 100,000 Newton acts on every 1 meter square of the surface of the Earth, object on the Earth. Okay. The average surface area of human body is equal to 2 meters square approximately. Average surface area of the human body is 2 meters square approximately. The atmosphere exerts a total thrust of 2 into 10 to the power 5 newtons on our body. Okay, but this enormous thrust, we do not feel it. Why? Due to the pressure of our blood, which that is the blood which is within us, that exerts a pressure. Okay, due to that pressure, we do not feel this atmospheric pressure, pressure outside our body, which balances it. Okay, the blood pressure is slightly more than the atmospheric pressure. And at high altitudes, what happens? The air pressure becomes less and the blood pressure is more. Okay, so what happens? Due to the height of the less height of the air column in the higher altitudes, our nose starts bleeding. Why? Because the inside pressure is more than the outside pressure. So what happens? The outside pressure is less and inside pressure is more. The pressure wants to release that. That's why it comes out. The blood comes out of the holes on our body. That is the nose. Okay. Next is to demonstrate the atmospheric pressure. Okay. How would you demonstrate this atmospheric pressure? How would you prove that there is atmospheric pressure? Okay. For this, let us take a can. We pour some water in the can. Okay. Like see in the picture, we have poured some water in the can and that can is heated till all the water inside the can evaporates. Okay. Now, it starts boiling and it forms steam and it will move out. That is, it will evaporate. The heating of the can is then stopped. Then the can is closed. Okay, with the lid. Then some cold water is poured on it, on the can. Then it will be, we will see the can will crumble inside. Why? Because the cold water that is poured on the can, the vapor inside the can condenses, creating a vacuum. Okay, inside the can, the vapor that condenses and it forms a vacuum there. And what happens when there is a vacuum? There's no air pressure inside, and the outside the pressure is there when we are pouring cold water in it. So what will happen? The can will crush its sides. Okay, so this shows that there is air pressure, atmospheric pressure, which presses, which exerts its pressure on every object on the Earth. Okay. Now, there's some consequences of atmospheric pressure. First, we will see that when we you take a glass of water and suck it through a pipe. So how is it possible? How can we suck the water through a straw? So for this, when a drink is sucked with the straw, first the air inside the straw is sucked inside into the lungs. Okay, goes out of the straw into the lungs. So what happens inside the straw? The air pressure decreases. Okay, and therefore, what happens when the air pressure is when the air pressure decreases, excuse me, the atmospheric pressure on the liquid of the glass that will be there, that becomes more than the pressure inside the straw, and that pressure will force the I will force the liquid to move into the straw. Okay, that will push the liquid into the straw, up the straw into the mouth. That is why you can suck the liquid through a straw. Okay. See from the picture, when the man is taking the straw, sucking the straw, the air goes inside the lungs. There's a air pressure inside the straw that decreases. The atmospheric pressure on the liquid is more, it becomes more than the air pressure inside the liquid, inside the straw. Okay. And therefore, what happens, this pressure will push the liquid into the straw and the person will suck the liquid. Okay. Next is the syringe. When a medicine or any liquid is sucked, is pulled inside a syringe, how is it possible? Okay, how that liquid gets inside the syringe. Okay, so for this, let us take a beaker in which there's some liquid. Okay, and we put a empty syringe inside it. Okay, so first the syringe is kept with its opening just inside the liquid and the plunger is lowered. Okay, this is the piston. Okay, first the piston is lowered. This is in the high position where the liquid enters. So first this piston will be close to the nozzle. Okay, so when this happens, so when this syringe is kept in that way, then its opening is just inside, with its opening just inside, the plunger is slightly pulled up in the barrel. Slightly, it is pulled up, very slowly it is pulled up inside the barrel. The pressure inside the barrel becomes less than the atmospheric pressure outside. Okay. When the piston was very near to the nozzle, there was no air. Okay. But when it is moving up inside the, it's pulled up inside the barrel. So what happens? There's a partial vacuum which has been created inside it. So what happens? The atmospheric pressure outside is more than the air pressure inside the barrel of the syringe. So what will happen? The liquid will move through the nozzle, through the needle into the syringe, into the barrel of the syringe. Okay, so that is how the liquid is pulled up by a syringe. Okay, same thing happens in water pump, where the water is drawn from the well, pulling up the piston. Okay, I think you are clear what I'm saying. Okay, next is fountain pen. When usually nowadays we don't use these ink pens, but these pens were used very much when we started writing first. When writing started, these fountain pens were the only pen which were used. Okay, but nowadays generally dot pens are used, but still let us know how this pen worked. Okay, so how to fill up the ink in the fountain pen? The tube inside the fountain pen is first pressed. When it is pressed, what happens? The air inside the tube, that will come out, creating a very low pressure inside the tube, air pressure, and the outside pressure inside the ink bottle, outside pressure will be more. And in this way, by pressing the tube, we put this pen inside the ink bottle. Now the ink bottle, which has more air pressure than the tube, that will press the liquid or the ink to move inside the tube through the nib of the pen. Okay, and this is how the atmospheric pressure will force the ink go into the pen. Okay, and it will be filled up. Or you can say, when the piston of the fountain pen is plucked up, the volume increases while the pressure decreases. Volume it is increased, but what happens? The pressure has decreased. The atmospheric pressure outside is more than the pressure inside the pen. Now, atmospheric rate forces the ink inside the fountain pen. Okay, same like that of the syringe. Next, rubber suckers. See, we use these rubber suckers generally in the kitchen or bathroom. Okay, they work due to air pressure. Then main principle is due to air pressure. So what is a rubber sucker? It looks like a small concave shaped rubber cap. Concave shaped cap with a handle like that. Okay, you just pull it, it will get stuck into the hole, and if we can pull it up and bring out those dirt which have been clogging the this one drains, and we can clear it up. So like that. So a rubber sucker is also, it can be also called a suction pump because it sticks to the surface by suction. Now what happens? How does it work? When a rubber sucker is placed on a flat or smooth surface, it's concave rubber cap. It's concave shaped like this. This is the concave shaped. Okay, this is the surface on which it is pushed, it is pressed. Okay, so concave shaped rubber cap, which gets flattened to the large extent, pushing out most of the air. So when this is pressed on the surface, it becomes almost flattened, and it will, this space which contained air, that will be forced out by pressing it. Okay, most air from the beneath, and when the rubber sucker is pressed on the surface of the air inside the sucker is pushed out, this reducing the air pressure inside the sucker, and therefore the air pressure is reduced here. As the air pressure outside the sucker is more than the inside pressure, it will press the sucker and keep it stuck to that place. It will not allow the sucker to move. It will press the sucker on the wall, on the surface. Okay, and thereby it can it can pull out the dirt which has been clogging the drain in the kitchen or bathroom. Okay. Sometimes hangings are also used, no? Hooks. Okay, that also used with the rubber suckers. Okay. Next, siphon system. Now, what is that siphon system and how does it work? It's a action of the siphon system also is a consequence of the atmospheric pressure. It also works on the atmospheric pressure. It is a system by which water is from the reservoir flows down without using a pump. Okay. So in this system, water is supplied from a higher level to the lower level. In this system, there are two vessels, C, P, and Q vessel. Okay. Now, vessel P is at higher level and vessel Q is at the lower level, and they are connected by a glass or a rubber tube. Okay, AB is the tube with one end which is immersed in, A is immersed in P and B is immersed in the Q vessel. Okay. Now, while the other, okay, to transfer water from P vessel to Q vessel, what happens? First, the air is sucked out from the lower end of the B of the tube. This air which is there inside the tube, that is sucked out from the B end of the tube. Okay. As a result, the pressure inside the tube decreases and it becomes less than the atmospheric pressure of the which is present in the vessel C. Okay. Due to the excess pressure at A, water rises in the tube. Excess pressure here, the water will rise inside the tube A at the end A. Okay. And it will reach to the level C, and then it will come down to B, lower level, due to the difference of pressure in water at the level C. Okay. And B. So there will be a difference in pressure and C and B. Therefore, that will come down to B. Clear how this water comes out? First, their vacuum, the pressure, the air is sucked out from B end, and then the water, due to the difference in pressure, the pressure here is more in the P vessel at the end A. So the water will enter inside the A, it will reach to C, And as there's a pressure difference, okay, here the pressure is more, here the pressure is less, so the pressure of the water will come down to B. Like this, the water is transferred from P vessel to Q vessel without using a pump. This is a Syphon system. And action of the Syphon system works on what? Consequence of the atmospheric pressure. Okay. Now we come to oil tank, oil can rather, you can say. When we use a sealed oil can, okay, so to take out oil from that, how it can be done, okay, so it is very difficult to take that oil out by making only one hole. We have to make one hole, no, to pour the oil from that sealed can. So it is very difficult to pour it by making only one hole. Why? Because this is due to the present absence of air pressure inside a completely filled sealed can. So for that reason, when the can is tilted, the pressure due to the air column, the column of the oil at the hole is much less than the atmospheric pressure outside the can. So the oil does not flow out of the hole. Okay. So one more hole is made at the opposite end of the top cover of the can. Air from outside the can will enter through that hole, through the second hole. Okay. And that will exert the pressure on the oil from inside along the pressure due to the oil column. Okay, that will help the oil to come out from the first hole. Clear now? So if this is the surface, see, this is the can with the surface of AB, okay? And what happens? We make a hole from this. Okay, only a single hole is made. At that time, what will happen? The oil which is filling up the can, can is totally filled up. So there is very less air inside it, okay, than the outside air pressure. So the air pressure inside the can due to the oil column is very less than the outside pressure. So this outside pressure will not allow the oil inside the can to come out. Okay. So another hole is made just opposite to this hole on that surface hole. Okay. So that air will enter through this hole. That will create a pressure on this oil level along with the oil column pressure, and that will help the oil to come out from this A. Clear now? Okay. So this much is the common consequences of atmospheric pressure. This is for today. We will discuss the barometer, okay, the benefits, the merits and demerits of the using a barometer, okay, in my next video. So till then, if you have any doubt, please go through the videos. If you have any doubt, please do write in the comment box, and also you can write at kasturi74@gmail.com. And please see the description box. You will get the links of the previous videos of this chapter, as well as the playlist links of the physics, chemistry, and biology of this class 9 syllabus, and also class 8, as well as class 7 and 6 biology videos. Also, you can get the playlist links also, as well as the link of my new channel. Okay. So please go through this. If you still face any doubt, please do write in the comment box. Okay. And till then, do meditate, do make a chart, and study in this way. Make a rough diagram that will help you in remembering and also recalling. Okay. That will help you in answering the questions properly. Okay. Keywords you will be able to remember by making pictures and write along with the pictures, write along the side by side what keywords, key points you want to remember. Okay, that will help you in recalling those points, and that will help you in solving, especially the one word answer or objective questions, you can say. Okay. So thank you. Thank you for joining and have a good day.